Hi everyone, I'm Kenneth. I'm really glad to see so many people. I was a bit like in doubt if actually anyone would show up here. So that's pretty cool. I'm really glad to see you. What I'm here to talk about today is basically how we can supercharge your JavaScript workflow inside Visual Studio Code. I am a program manager working on our JavaScript diagnostics team. So that means my team is building the developer tools we ship inside Edge, our browser. They're called F12. We ship our JavaScript debuggers we do for Visual Studio Code. And then we also do a bunch of other JavaScript-related things for Chakra, our JavaScript engine, Node Chakra, our variant of Node, and also what we do for Azure, our cloud. So basically, we do a lot of different JavaScript-related things. But today, I'm here to talk about Visual Studio Code that is hopefully shouldn't be a new thing to a lot of you. It's our cross-platform open source editor. It's Electron-based. It's basically just a web application wrapped as an Electron app. And like before I dive into things here, how many of you are using code today? So almost all of you. That's fantastic. I think like if you look at code and compare code to other editors, there's one thing that makes code stick out from Sublime Text or Atom, and that's basically our integrated debugger experience. Because if you look at like what we provide in code, it's basically a way that developers can build plugins for code, so you can have this integrated debug experience that a lot of I would say traditional Microsoft developers are used to when they're coming from .NET and inside Visual Studio. The fact that you can set a breakpoint, you can debug your code from where you wrote it, is a concept that from a lot of users that are coming from the Unix stack, when they're coming from Vim and TextMate and other tools, that they don't have that capability available. And frankly, that's what I want to talk about today. And I want to talk about integrated JavaScript debugging, because if you look at JavaScript is really the language that touches almost every developer today. I think as you saw part of the keynote yesterday, we are doing a lot for JavaScript in our cloud Azure. JavaScript is running inside the browsers. We're doing JavaScript on the servers with Node. But also JavaScript is running off hardware. Basically, JavaScript is running everywhere. And yet JavaScript is kind of one of these languages that is really hard to debug because there's no great tooling available. The first thing I want to talk about is debugging server-side JavaScript. And particularly, I want to talk about the workflow a lot of developers have each and every day when they're debugging Node code. Because it's basically a lot of console.logging. We do this like a gazillion thousand times a day. Stop our process, add some console logs, and continue. And the interesting thing when we actually look at what a typical developer workflow is, you start your editor, you open up your project or your code in your editor, you start Node from the terminal, you add some console logs if something is not really working, you switch to the terminal, you look at the terminal output to see what you're actually logging out, then you switch back to your editor, and then you try to fix the problem. And then this is kind of like the continuous process that you're doing probably a few hundred times a day, right? And kind of like what we've been asking ourselves on the JavaScript diagnostics team is basically can we do better? Is there a better way? And frankly, there is, and there's a way that we're shipping outside of, as part of the box for code, actually. And that's basically our VS Code Node debugger that we're shipping as a part of the product. And basically what this debugger does is it enables VS Code to connect to your Node process and enables you to have a rich integrated debugging experience that a lot of, I would say, traditional .NET developers are used to. And you can actually just press F5 inside code, and you can debug your code by setting at a breakpoint. You don't need to do the console logging nightmare that a lot of us are actually doing. And basically, if you look at what this kind of experience provides, it provides a more holistically integrated experience where you can start your editor, you can open your code, you can actually start Node directly from your editor, you can set breakpoints, and you can debug your code straight from the editor instead of doing all the console logging. And then you can actually fix your problem from your editor. So you actually don't need to leave the editor, but you have this integrated workflow that we have seen a lot of developers are quite happy with, but it also makes them really productive. So I just want to show a quick demo. Is there anyone here that is using Node, this debugging experience every day? there's only a few hands, so this is actually it's pretty good to actually demonstrate it. I should probably bump the font size. Is this good? Cool. So basically what I have here is that I have a simple Node application. This is my server.js. My server.js file is pretty simple. It's a little Express app that is having a time zone API endpoint, and basically just returns some data, making an API request and returning some data. If I had a problem in this, like in my traditional way, I would be adding a lot of console logs and then start and restart my process. But what I can do with VS Code is that I can actually go to the debugger tab here, and then what you see here is that I have a node configuration. I can also say add configuration, and then you can see here I can choose some templates on how I configure the debugger in VS Code. I've already done this, so what I have here is a little JSON blob, a little object that describes how VS Code should be connecting to Node. I want to launch Node. I want to use a new protocol called inspector. I'll be touching that in a moment. And then I want to run npm, and I want to call npm with run script and my start script. And I want to use integrated terminal inside VS Code. So with this little configuration in place, I can go to the debugger here, and I can just press this little green button. And what you're seeing down here is basically my Node server is booting up, starting my process. It takes a little while to start up. And now my application is booted. What you see down here is basically that all the terminal output is outputted inside the integrated terminal. So I actually don't need to leave VS Code here. And what I then can do is that I can just go to my server, and I can set a breakpoint in my API request. And then I can try to use my demo application here that is basically a little time zone converter. So I want to, for example, add San Francisco. And now you can see, now I'm breaking on my code directly inside VS Code. I don't need to add any console logging to figure out what's going on. And I can, for example, see that I got actually my request from the API I was calling. If I go to the debugger UI, I have the full call stack, where I can go back in time, or basically I can swap between stacks if I want to. I have variables, everything you're kind of used to from any other browser dev tool, but you just have it integrated as a part of your editor. And what we're seeing here is that you have a much more efficient workflow because you don't need to leave the editor and start and stop your process. So this is just a quick demo on how that actually works. But if you look at some of the more recent work we've been doing is Node 8 that is just around the corner, and Node 8 is introducing a breaking change. It's introducing a new remote debugging protocol, a new way that editors and other tools can talk to Node. And they call this the inspector protocol. And I just want to say that our debugger is already working with Node 8, and what I demonstrated here was using the inspector protocol. So we're already up to speed in terms of enabling that support. Another thing we've been asking ourselves, what about client-side JavaScript? What about all the JavaScript that we actually write outside of your server context? And actually, if you take a look at the workflow again, for client-side developers, it's actually much more complicated. Because usually, client-side developers, they open the browser, go to the editor, navigate to the app in the browser. Then they also try to find the same files inside the editor. They make a change inside the editor. I need to go to the browser, refresh the page. Then they probably need to open the browser dev tools, look in the console and script debugger to find what the error was. Then they go to the debugger inside the dev tool, find the same file they just opened inside the editor. Then they set their breakpoint there. Then they debug in the browser dev tool, regardless if it's Edge dev tools, Firefox dev tools, or Chrome dev tools. And then once you have narrowed down what the problem is, you switch back to your editor, and then you fix your problem. And the interesting thing when we actually outline this kind of rather complicated web development workflow is that as a web developers, we kind of just used to this because, hey, this is how we debug stuff. It's something we don't think about. And the more interesting thing is when we actually talk to web developers, we have noticed the thing that a lot of web developers don't realize that this is actually a problem. There's a more efficient way of working. We kind of call this the web developer Stockholm syndrome, that it's perfectly all right to sit and tab and switch between browsers, editors, and terminals. And the good thing is, we spent a little time last year trying to see is there anything we could do about this problem. So VS Code also has like this marketplace of extensions, and what we did was that we released a Chrome debugger, basically extension you can install if you want like an integrated browser debugging experience inside VS Code. It has turned out that it's one of our most popular debuggers because a lot of developers actually want this experience. Our Chrome debugger is a bit interesting because it can debug client-side code, but it's also framework agnostic because it's just a JavaScript debugger. It can set a breakpoint in JavaScript code. But there's this interesting like paradox that arises when we do client-side code is that the code that we are writing and what the browser is seeing is quite different. Like we are compiling our code with transpilers, we're sitting in framework abstraction, we're sitting in JSX, and then the browser is seeing HTML. So we actually spend quite a bit of time on figuring out a way where we can build a debugger that is based on source maps. And basically what our debugger is able to is that we can basically like map the served asset that the browser, the runtime is seeing to your source files. And we do this completely transparently. The only thing like you need to do is that you need to tell the debugger, this is where my source files are, and then we try to figure it out for you. And if you look at like, if you compare that to the workflow we had before, then like browser debugging with this is much more simple. You open your editor, find the file in the editor, you browse, you can basically open your browser from the editor, you can debug inside the editor, you can set your breakpoints, and you can have like this holistic experience without leaving the tool, and you can fix your problems right within. And then another thing that we're doing is basically we are able to, because we can source map the served code to your real source, then we can also show errors inline inside the code where you wrote it. And I think it's like, this is a lot to take, so it's a bit easy to show a demo in terms of how this works. So if I go back here, like my debugger here, or VS Code, is still connected to my node process. But then what I can do is that I can go to my launch.json, and then I can add like a configuration on how to connect to Chrome. And basically what you're seeing here is basically a similar config. Say, hey, I want to launch Chrome debugging. I want to launch Chrome in this URL. This is my VIP route. This is basically where my source code is located. What I then can do is that if I go to the debugger tab, I can now select Chrome up here. And if I press the green button, what you're seeing is an instance of Chrome opening here. Let me just resize my windows. What I then can do is like I can go to my client-side code. That in this case is just a React app application. It's used in Webpack. It's actually built on top of a great React app from Facebook. So kind of like a standard like packaged app. What I then can do is that I can actually go to one of my components here. That is a place component that is showing like a place in the world. And what I can do is that I can, for example, find on time double click and set a breakpoint. When I then double-click in my browser, what you'll then see here is that we actually tell Chrome, hey, we're paused in Visual Studio Code. And what you have here is the same debugging experience as you had before with Node, but now we're actually debugging your client-side code. And if you go into the debugger here, you can basically see that our call stack is like, we're still connected to Node down here, but now we're paused in Chrome. So now we kind of, Visual Studio right now, Visual Studio Code is connected both to the Node process and the Chrome process. And what you have here is like the same experience. You can step over code. You can see like local variables changing. But the key thing here is that you don't need to leave the editor. And you can connect this to any instance of Chrome that is running locally. So I think like this is a really powerful workflow that we can actually bring this integrated experience inside the editor, and you don't need to open up another dev tool. But kind of what we've been asking ourselves here lately is like, is there a better way? Can we even do more that is more efficient than this? And there is, because if you look at like how a lot of us are building applications today, like we want live editing. We want like a live editing refreshing experience. And basically what we released a few months ago is basically we added support for basically real-time updating of source maps. So if your bundling system like Webpack is supporting hot module reloading, our debugger supports that. So basically we're going from like a workflow where you need to make a change, switch to the browser, refresh, see your result, switch back to VS Code, to where you can make a change, see the result, and you can fix your things right away. So this is a much more efficient workflow when you're debugging. And basically, the live editing mechanism I want to demonstrate here is based upon Webpack's hot module reloading. If you're using another bundle that has a similar mechanism, then our debugger works with it. But our debugger itself does not do all the live reloading magic. It's basically up to what kind of bundle or what you use in your system. What we do is that we read the source map that is generated and emitted, and then we handle it from there. So this basically enables us to be like bundler/framework agnostic. And out of the box, we are working with React boilerplate, we're working with the Create React app, we're working with the Angular boilerplates, so because we're platform agnostic here. In this demo that I'm showing, I'm using Create React app, we are part of the documentation and all that stuff. But like, let's just show like how this actually works. So what I have here is Chrome and my application. So if I try to like add, for example, a new place up here and say San Fran. My internet is working. Can I say Copenhagen? Interesting. Come on, internet. Yeah, there we go. So what you see now is like, first of all, I'm breaking on my server-side code right now. So I'm basically doing the API request. But what you're seeing now when I go here is that now we are breaking on the client-side code running inside Chrome. And what you're seeing now is actually a type error. So we basically source map the stack trace or the file from the stack trace, identify that in the editor, and pointing you to that specific line where the error occurred, and telling you what's wrong. Cannot read the property addresses of undefined. And if I look at my response data here, response.data, then I have addresses. I am purposely introduced like a .data error. So if I remove this and press save, what you're then seeing as soon as I continue is that now live reloading kicked in, and if I do the very same thing again, then my API endpoint is being hit and San Fran was added. I never needed to leave the editor, but have a holistic, integrated live editing experience. And I can do this across stacks. I can break in my server-side code and in my client-side code. I think this is pretty cool. But then we're asking ourselves, like, is there a better way than this? And there is, because we released a feature that we call compound JavaScript debugging. That is basically a more integrated experience where you can start both your client-side debugger and your server-side debugger at the same time. And this basically is what we call like Nirvana JavaScript debugging, because you have one configuration file and you click F5 and then everything boots up. And the way this works is actually relatively simple. So if I go into my VS Code launch file here, we have something we call compounds, which is basically just a configuration that allows you to say, my new debug target here is full stack. And by the way, when I mean full stack, you should start my Node config and my Chrome config. And what you then see here, I just need to kill one, yeah, like that. What you then see if you go to the debugger is that you can now select full stack. And when you press go here, what we're seeing is that Chrome is starting, my Node server is booting up. Now it's like doing the React stuff, and then I'm seeing my application. But it's all integrated. And now I have the exact same debugging experience as before, but I just press F5 once, and we can start up different targets. I think this is really powerful because this gives you like this Nirvana integrated experience that a lot of us developers really want. But the more interesting thing about this, like VS Code is built on a flexible architecture. So this means that this scenario is not only enabled with Chrome and Node. You can also do it with our C# debugger and Firefox. You can use our Go debugger that the community has built with Edge, because we have an Edge debugger available. We are basically just composing different debugging configurations together, and because we have like these debuggers available, we can give you this integrated experience. And I think, now I have like 40 seconds left here, I think what I've shown today is that we have gone from this much typical debugging workflow to a much simpler web development workflow if you build modern applications. The application I just demonstrated before was actually two separate applications. It's a server-side part that is using an API running on one specific port, and it's using another web server serving my client-side front end. In theory, I could be debugging, configuring my debuggers to debug a cloud instance. I could debug it on another machine. And if you look at the workflow with a few lines of configuration, then we have a much supercharged, but also a much better experience. So my ask for you is that I would love for you guys to try it out, give us feedback in terms of what you think about this. And that's basically what I had to talk about today. The VS Code booth is over here. We also have a Visual Studio Diagnostics booth. So if you want to talk about debugging and you have any ideas or ways we can improve things, please let me know. Thanks.